Hello, everyone. Apologies for this week. It seems like it's one thing after another. Uh, One of our students from the online class, Devin English, we tried to record Friday morning, and I was kind of worried going into it that my phone with memory, would kind of not be good. And sure enough, we only got two little mini clips of like maybe 6, 7 minutes of um, me going through this section. Um, but then to make matters worse, I downloaded the YouTube app to my phone and I tried to upload it uh, to my YouTube page through the app. It would not upload. It's saying it's uploading, and then when it gets to like 99% of the it says error in upload. And unfortunately, there was a couple of good friends of mine from back in Maryland in town this week, and I was with them, so I thought I'd have everything loaded early, and sure enough, I haven't been my laptop around, so I haven't been able to use my phone. So apologies that um, there's been no video this week. I know the test was uploaded in plenty of time, but I definitely wanted to have a video kind of demonstration, lesson for this um, section of the book. Thankfully, this lesson is very short, and like I said in the on the lesson on the not blog, but actually reading in the lesson for the week, that it's probably the easiest one for the whole you know semester. Uh, So, but I still want to do a video just to be a quick run through in case you haven't taken it and you want to kind of have just kind of a general idea. There's really not much I can say outside of what the book says with this one. Like I said, it's pretty straightforward. There might be just one or two maybe little things I can add to the book. For the most part, though, ratio and proportions are pretty simple. The only reason I wanted to split it up is because percent is so large that it almost isn't fair to try to pack it in a week with other things. So even though it's one big section in the book, I didn't want to try to do a 20 page, work week. So just talking about ratios and proportions real quick. This should just take a few minutes. Ratio is a comparison of two quantities, and as you can see, there's many examples there being used. Three things, it can be written something to something, the word actually to, with a colon or as a fraction. And like I said, the only place these get even somewhat tricky is just to make sure that you write them in order. Um, and it's not the order that it's sometimes in the sentence or the statement, it's in the question. It's how the question is asked. So um, it can give you a bunch of information, say that you're making a recipe and you need 4 cups of flour for every one cup of sugar. Uh, but then the question could say, so in the order of the sentence, it says flour then sugar. But the question then might say, what is the ratio of sugar to flour? That's where the order comes in. That's where it's most vital. So if the question that you're answering asks what's sugar to flour, it would be 1 to 4, or 1 over 4, or 1:4. Even though flour came first when it was giving you the information, the actual question asked ratio of sugar to flour. So make sure that's the only place that some people kind of get these a little bit messed up. Um, Once in a while, people do. I've seen in the past get they always want to put the smaller number first because it just you're so used to seeing fractions like 1/4, not 4/1. So sometimes people can get caught in that mindset of putting the small number first. Remember, that's not the case. It's simply in the order of however it's asked. Um, so the equal ratios, that's pretty standard stuff. It's like reducing fractions, or in this case, it can be increasing fractions, but you're either multiplying or dividing by the same number. If you have 2/5, or 2/5, 2/5, And an equal ratio would be if you multiply both of them by 3, so you'd have 2 times 3, which is 6, 5 times 3 is 15. So 6 over 15, 2 over 5, or 2 to 5 and 6 to 15 are the exact same ratio. They're equal ratios. In the video I did with Devin the other day, we did one with a pizza or a circular, you cut into different sections, but obviously, I can't do that here because it comes out backwards. And the chart at the bottom of page 82 is the flow chart, the 3 for 2, 3 cents for every 2 cans. That's just a general way of seeing the ratio going out. It starts out at 3 to 2. So if you bring in 3 cans, you get 2 cents. Bring in 6 cans, you get 4 cents. 9 cans, 6 cents, and so on and so forth. It continues that same pattern, 3 to 2. The ratio of cans to cents, 3 to 2. And the bottom one, same way. It's 5 to 2 length to width for a factory. And then we jump over to proportions, and of course proportion, as it just says there, is 2 ratios that are equal. And, so basically you just found equal ratios, and now we define them, and the equal ratios are defined as a proportion. And like I just gave you the example, there's one there at the top, 3 to 4 is the same as 6 to 8, exact same ratios, and that is called a proportion. Same value, just different numbers. And then throughout that page, you're basically just identifying yes or no proportions. How you can identify them, like we just said, if sometimes they're really easy, you can say, well, if 4 over 8 and 1 over 2, you can tell because 4 is half of 8 and 1's half of 2. That one's easy. You can just look at that one. You don't have to do any math and tell that that's a proportion. Sometimes they can get a little tricky, like it shows here in the book. The example at the top, 9 over 12 and 15 over 20. Well, 9 doesn't go into 15 evenly, 12 doesn't go into 20 evenly, so you're kind of like, well, I don't know if that's a proportion or not. The way you check those is you cross multiply. Multiply the numerator of one fraction by the denominator of the other, and then multiply the numerator of the other fraction by the denominator of the other one. So you're just crossing and multiplying. If those numbers equal each other, it is a proportion. And as you can see there, 9, 12, 15 over 20, they do work out. They both, if you multiply 9 times 20 and 15 times 12, they both equal 180. Therefore, that is a proportion. And on the other side of that example, 4 over 6 and 24 over 30, if you cross multiply there, you get 120 and 144. Therefore, it is not a proportion. Having 4 parts out of 6 is not the same as having 24 parts out of 30. And the rest of that page, you're just identifying proportions. And again, some of them you can look at very, very easily and tell. Other times you might have to do the cross multiplication to see if they are indeed a proportion. And then just to expand on that, the next page, you're writing the proportion based on the information given. So you have, when you write these, you're almost always going to see them in fraction form, so the examples, Joel drives 75 miles an hour. You can stop right there. That's a ratio. It's telling you that he drove 75 miles in 1 hour. So there's your 2 units. There's your fraction, 75 and 1. 75 miles, 1 hour. The next part will tell you how long it will take him to drive 375 miles. So the information you're given is the other miles. So in the proportion, picture 2 fractions here, I got 75 over 1 on this side. So the 75 miles, and then, so it's important to know your units. 75 miles on top, 1 hour on the bottom. Then what happens, we need to line up the units as either both the denominator and both the numerator and both the denominator. So if you put 75 miles on top over here, 375 miles has to be on top over here, and then the hours will be on the bottom. 1 on this side, and we don't know how many on the other side. So that's just setting it up. That page right there is just for setting up the proportion. You don't need to solve it just yet. It just wants you to get used to setting it up. And like I said, the only tricky thing there is to make sure that the units line up with the units. So if it's like we said earlier, like flour and sugar, 4 cups of flour to 1 cup of sugar. So you have 4 F you can put on top, 1 S on the bottom. So if over here, well then, how many cups of sugar if I need if I have 10 cups of flour? Also, if I have flour on top over here, I need to put flour on top over here on the fractions. Pretty simple. Again, the examples they give you are great to follow along. Um, Seeing me on the board probably would have been even easier, but we'll get there. In the next page, then you're solving the proportion, and how you solve for that missing number is you cross multiply the two numbers across from each other and divide by the other one. So in the example at the top there, Joel drives 75 miles an hour. How long will it take him to drive 375 miles? And you can see the setup: miles on top, hours on the bottom, 75 over 1. They have the 375 on the top on the right. The unknown number on the bottom is how many hours. So you multiply the 375 times the 1, you cross multiply them, and divide by the other number, which is 75. And that gives you 5. So it's 5 hours to drive 375 miles. And that page is pretty much all you're doing. Is you can see the n is the missing number from all those proportions. So cross multiply and divide is all you need to do for that whole page. And some of them are pretty easy. You don't even have to do the cross multiplying and dividing because some of them are just pretty straightforward. Let's see, where's a good one? Even number 3, you can see it's 3 over 8 equals 15 over n. Without cross multiplying and dividing on that one, if you look, 3 goes into 15 how many times? 5. So you got to take 3 times 5 to get to 15. Well, if you multiply the top by 5, multiply the bottom by 5. So 8 times 5 would be 40. So in that one, n would equal 40. You can kind of do some them like that if you can see that right away. It's pretty much a shortcut, get right to the answer. But like I said, you can always do the cross multiply and divide to get the answer. And the next 2 pages, which is pretty much all we did for this week, is a unit rate. And all a unit rate is simply finding out how much it is for one unit of something. So if I go to a store and they have a big sale, 5 shirts for $45, and I say, well, then how much would it be for one shirt? And obviously the easiest way is, well, 5 into 45, that's 9, so it'd be $9 per shirt. But in reality, what you've done is kind of done a proportion. So if it's 45 over 9, over on this side, I want to know how much is for 1. So 1 times 45, 45 divided by 9, which is 5. You've done a proportion, and you didn't even realize it. And there's a couple examples up top. Cheryl can walk 4 miles in an hour. Therefore, her rate of speed's 4 miles per hour. It starts with the. It starts out just telling you what a unit rate is. It's the rate for just one of whatever you're discussing. So in my example I just gave you, it's for one shirt. Here it's for 1 hour. You can walk 4 miles. In 1 minute, she can type 95 words. And there's a couple examples of like I said, the basic unit rate, and then the bottom. Basically, for all those, you can divide like number 1, 91 tiles to make 13 hot plates. How many to make 1? Divide 91 by 13, get yourself 7. So those are very, 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 very basic, stuff that we do a lot in real life and don't think about identifying as like, well, I just found a unit rate. I just did a proportion there. You could wow your friends now when you go somewhere and say like, how much cost for one of them? That's proportion. So, of course, I do that because I try to make math cool, and it's not to a lot of people. So, and then the last page, the use unit rates to make comparison, is simply you're taking 2 different scenarios, 2 different units of measurement, and breaking them down to find out how much it is per one, and then just comparing them, which one's faster, or which one gets better mileage, which one's a better buy. The only time you can get a little bit caught up on that page is be careful that obviously which one's faster, you want the bigger number, whichever one's bigger for one. But what's a better buy, you want the lower number, you want to spend less. Okay, so just be careful with that. For example, number 1, which is faster, 132 miles in 2 hours. So how much is it for 1? Divide the 2 into the 132, you get, I believe it's 66. And then for B, 335 miles in 5 hours, which is 67 for 1. So therefore B is bigger. 67 is bigger than 66, therefore B is faster. And that's all you're doing for that page. Just finding out the unit rate for one, whatever it may be, 1 hour, 1 gallon of gas, $1, and boom, you're good. And that's it for this page. So the test is up. Like I said, I think this should be. I hate to say stuff like that because then if somebody gets a bad score, then I feel like I'm, really insulting them, and by no means do I mean it that way, obviously. But I do think everyone should do well this week. Percents is a big one, so hopefully we can get jump started into that one pretty early. I can upload a bunch of stuff. There'll probably be a lot of examples I'll use for percents because it's real life stuff. It's stuff that people do use. A lot of times you get asked, what do you use in the real world with math? Well, percents is definitely one of them. So next week's a big week. So just kind of tell everybody to try to get locked in early and get as much time in as you can, because I can promise you that next week's tests will probably be, if this one's easiest, that one might be the toughest. Just because there's so many different little nuances with percentages and different ways to solve them and different ways to kind of read them. They can be tricky. I'm not trying to scare everybody, just being honest. So that's it for ratios, proportions. I probably talked a lot longer than I even needed to. Again, hope everyone's having a great week. Look forward to talking to you soon. And I'm trying to, like I said, we'll get this whole thing lined up to video. I need to delete a lot of stuff off my phone or get it downloaded or something. Anyway, I'm rambling. Have a great night.